All right, IM2 classes. Today we're talking about properties of radicals. You might be thinking, what is a radical? Radical is just a square root. It could be a cube root. It's just the root. And that's what we're going to be doing today is dealing with roots, specifically square roots. We're going to be simplifying them and dividing them a little bit. Just some things I want you to think about before we get into the lesson. With square roots and how if you can add them or subtract them or multiply and divide them and how that stuff works. So asking a quick question in general, is square root of a plus square root of b the same thing as square root of a plus b? To figure that out when we look at this example up here. So we'll evaluate both of those. So square root of 36 plus the square root of 64. Let's do those square roots. Square root of 36 is 6. Square root of 64 is 8. 6 plus 8 is 14. All right. But what if we add them together first? So is it the same thing as square root of 36 plus 64? So let's do that. For this one, you would need to evaluate, you need to add those together inside first. So 36 plus 64 is 100. Square root of 100 is 10. Looks like they are not the same. So can you add square roots together like that? So is the square root of 36 plus square root of 64 the same thing as square root of 100? No, it is not. You cannot add roots together like that. All right. But let's look at multiplying. We have the multiplication. Let's do that first one. Square root of 4 times square root of 9. Square root of 4 is 2. Square root of 9 is 3. 2 times 3 is 6. So let's do the other one. Square root of 4 times square root of 9, or square root of 4 times 9 here. So this one we got to multiply first on the inside. 4 times 9 is 36. Square root of 36 is 6. So these work. So when you're multiplying with roots, you can actually put them together. So these are the same. You can't add roots together, but you can multiply. Same thing. Let's do this with subtraction. Here's a hint. It's going to be the same as addition. So let's do square root of 64 minus square root of 36. Is it going to be the same thing as square root of 64 minus 36 there? Square root of 64 is 8. Square root of 36 is 6. 8 minus 6 is 2. All right, let's see if it's equal to, if we were to do 64 minus 36 together like that. 64 minus 36 is going to be, what was that, 28? Square root of 28, that comes out to 5 point something. Not sure off the top of my head, 5.3 or so, something like that. No, they are not the same. So you cannot subtract roots like we have up here. All right, down here, let's do this last one with division. Square root of 100 divided by square root of 4. Let's simplify that. So square root of 100 is 10. Square root of, okay. Square root of 100 is 10. Square root of 4 is 2. 10 divided by 2 is 5. So let's do it if we put them all under one radical. So square root of 100 over 4. Let's divide that first. So that's going to be 100 divided by 4 is 25. Square root of 25 is 5. So what we learned from this, you can add, or excuse me, you can multiply and divide radicals and getting the same thing. So when you're multiplying or dividing, you can squish them all underneath one radical. Same thing with multiplication. When you're multiplying, you can squish it all underneath one radical. If you're adding, you cannot squish it underneath one radical. You cannot combine roots when you're adding and subtracting. So let's get into the lesson of simplifying radicals. What we're going to do here is what I like to call the buddy system. So we're going to simplify this. We're not just going to put it into a calculator. We're going to put it in what's called simplified radical form. Write that out up here. Simplified radical form. So what this means is we are going to put it, so it's going to be, we're going to separate it out into, it's, we're going to take out perfect squares is basically what's going on. I'm going to do the buddy system. So what I'm going to do with 108 is I'm going to factor this. What are two numbers that multiply to get 108? That's going to be 2 and 54. 54, I'm going to keep going. 2 is prime, so I'm going to keep going. 54 is 2 and 27. 27 is 3 times 9. 9 is 3 times 3. So I have all these radicals. I'm going to put them back underneath here. So 2 times 2 times 3 times 3 times 3. So what I'm going to do from here is I'm going to look for buddies. This is why I call it a buddy system. For every pair, and they have to be the same number. So for every pair, I have a set of buddies here, a pair, one of those numbers goes on the outside, cross it out. All right, I got another pair of 3s here, and I'm just looking for 3s or for pairs, cross it out. And then multiply things back together. So 2 times 3 is 6, is going to be on the outside, and then I'm going to have a 3 on the inside. What's going on with this? All right, is do it up here. What we're doing is we are separating out 108 into a perfect square, which would be 36 times 3. And then we're using that fact that we can separate out when radicals are in here like this. We can separate it out into two separate ones. So square root of 36 is 6. 3 is not a perfect square, so we leave it like that. I just find, instead of guessing and checking, to find a perfect square that divides this number, it's easier just to do a factor tree. So I'm going to do the same thing with this one over here. So 9 is 3 times 3. And then I don't really need to do a factor tree on the x cubed. What I'm going to do is expand the x cubed. So it's x times x times x. And then I'm going to look for pairs again, look for buddies. I have a pair of 3s. For every pair, one goes on the outside. Then I have a pair of x's. For every pair, one goes on the outside. Cross them out, and then multiply things back together. So I have a 3x on the inside, root, and there's an x on the, 3x on the outside and just an x on the inside. All right, 24, let's do this one. So simplify the expression, again, buddy system. 20 square root of 24 is 2 times 12. 12 is going to be 2 times 6. 6 is going to be 2 times 3. So I'm going to put all those. I have 1, 2, 3, 4, or excuse me, 3 2s and 1 3. I don't put in anything. I only put in the numbers that are at the bottom of the tree. So no 12, no 6, just the numbers that are at the bottom of the tree. So 2 times 2 times 2 times 3. Look for buddies. I have a pair of 2s, and only pairs. This 2 doesn't have pairs, so it's going to stay in there. 2 on the outside. No more pairs. I have a 2 and a 3. Those don't match, so I'm just going to simplify from here. So I have a 2 on the outside. 2 times 3 is 6 on the inside. And that's it. Negative 80, we don't even really need to worry about the negative. We just can't forget it at the end. So I'm going to factor this. 80 is 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. And then those aren't going to factor anymore. So I have 1, 2, 3, 4 2s and 1 5. So I'm going to see, okay, let me fix that before I get too far. So 2, 1, 2, 3, 4, and a 5. And so now I'm going to look for buddies. So I have a pair of 2s. For every pair, one goes on the outside. Another pair of 2s. For every pair, one goes on the outside. And then I have, don't forget the negative. Bring down the negative here. So it's going to be negative 2 times 2 is 4. So negative 4 on the outside, and there's still a 5 left on the inside. And there we are good with that. Yeah, sure. 49 is 7 times 7. Those don't factor down anymore. So it's going to be 7 times 7. I'm going to expand the x's. Fix that. So expand the x's. Now I'm going to look for buddies. I have a pair of 7s. So for every pair, one goes on the outside. And then a pair of x's. Wow. Pair of x's coming up. For every pair, one goes on the outside. No more pairs on the inside, so I'm going to multiply this out. So 7x on the outside and 1x left on the inside. I'm not going to fix that one. You're just going to have to deal with it. 7x times the square root of x. All right, I think this will be the last one we do. But 75, that's 3 times 25. 25 is, it is doing it more, I swear. 25 is then 5 times 5. So all I'm going to do is put those in here. So I have 3 times 5 times 5 and n to the 5th. I'm just going to expand that. 1, 2, 3, 4, 5. 5 n's. And now look for pairs. Look for buddies. Pair of 5s. One on the outside. I have a pair of n's. One on the outside and another pair of n's. Another pair, I'm going to put one on the outside. No more pairs, so I'm going to rewrite this. So 5 times n, that's going to be 5n squared, square root, and I still have a 3n on the inside, so 3n. There we go. Some problems. Moving on, we're going to work on the quotient property, so we're going to divide. Just like what we were talking about, what we can do when we were dividing with roots is you can split up into 2 roots and just take the root on the bottom, right? So really what this is going to be coming down to is we are going to simplify, and we're just going to be, it's going to be perfect square on the bottom. But let's do some examples here. So square root of 15 over 64. So here it's going to be, oh, you don't want to do it like that. I'm going to split this into 2 radicals. So square root of 15 on top over square root of 64 on bottom. Square root of 15 is not a perfect square. Square root of 64 is 8. What you should do, just check to see if you can simplify the top using a buddy system. So 15 factors to the 3 times 5. There's not going to be any buddies. That's it. So this one here, square root of 81 on top over square root of x squared. Square root of 81, that's one you should know. Square root of 81 is 9. Square root of x squared, the square root and the square root just cancel each other out. You just have 9 over x. That's it. So you're going to separate out the radicals into a top and bottom and simplify where you can. Let's look at another example. Square root of 23 over 9. So square root of 23 over square root of 9. 23 is a perfect square, so that is not going to simplify any. So this is going to be square root of 23. 9, square root of 9 is 3. That is super annoying. I should have just left it, but I'm fixing it. Too late. So square root of 23 over 3. All right, the negative we don't even really need to worry about. Just don't forget it with your final answer. Square root of 17 on top over square root of 100. Negative out in front, square root of 17. That is a prime number, so it's just square root of 17. Square root of 100 is 10. That's it. Square root of 36 over z squared, so that's going to be square root of 36 on top square root of z squared on bottom. Square root of 36 is 6. Square root of z squared is just z. Done. Sure, we're on a roll. We'll keep going. Square root, we're separate out, so to two radicals, so square root of 4x squared over square root of 64. 4x squared, you could do a buddy system on that one. Everything's going to come out. It's just going to be square root of 4 is 2, square root of x squared is just x. So it's 2x on top, square root of 64 is 8. We're not done yet. Notice that we have 2 over 8. And actually, we could have simplified this first, but I wasn't paying that close attention, so we're not. We notice here 2 over 8 reduces. You can divide top and bottom by 2. So 2 over 8 reduces to 1x over 4, or just x over 4 if you prefer. You could simplify this first. So if I take it, just rewrite it. Here 4 over 64, that is going to simplify to 1x over 16. You could also do that and you'll end up with the same answer. So you can reduce first if you want, or reduce at the end. Just be looking out for if your fractions reduce. And that will do it. Next time, not sure what we're doing. But yeah. There we go. And